Keith, take it away.
Oh, neat. I get to do an intro? Lovely. So it's my pleasure today to introduce Joe Paymer. Joe's currently supporting Instagram's developer tooling team as engineering director. He's got a long track record of both building and leading teams building engineering tools. So if you don't use Joe's code, you probably use the code that of people who use Joe's code. I really enjoyed getting to know him in the course of prepping for our talk today, and it's a humdinger of a talk, should be worth your while. And I'll also be curating questions for the Q&A after he's done. And with that, I'll hand off to you, Joe.
Thanks so much. I was hoping you get to introduce yourself, but we can get to that later, I guess, or if you want to take the floor. But
yeah, sure, okay. So I'm Keith Adams. I long before Joe was on board the Facebook mothership, I was working on the HHVM and Hack runtime and languages at Facebook, and then I was at Slack most recently for 4 years as chief architect. I spent 2020 trying to pursue various personal projects between the global crises, including making enough time to participate in community events like this one here. And I'll be curating some questions for Joe as we go along. Please keep them coming. I know my first question is going to be about the artwork for his slides, but if we don't get to that one.
It's from a very talented and obscure artist whose name I'm not at liberty to reveal just yet. All right, cool. Well, thanks so much, Keith. It's great to talk to you and get to know you. And honestly, also, thanks so much to all of you for having me, especially to the organizers of this conference. I can't imagine, organizing something like this under more challenging circumstances. But I don't know about you all, but I've been having a blast tuning into all the talks. And I really, really, really deeply appreciate the opportunity to come here and talk to you about some things that are near and dear to my heart today. So thanks again. So just to kind of set expectations for today, this is a talk about what I think it takes to build good software tools, or as I'll refer to them throughout the talk, just tools for short. And by this, I don't mean necessarily scripts or small utilities. I mean like the kind of stuff that takes lots of engineers, lots of time, lots of energy, lots of money to build. The big things like languages, IDEs, editors, UI frameworks, build systems, all that good stuff. I'll talk a little bit about why I have a perspective on this in a minute, but first, my first misdirection, which is that this isn't actually a talk, this is really a rant. Because from where I am and where I've been, I see a lot of the same mistakes being made when building new software tools. I've been, as you could imagine, developing certain opinions about how I think they should be constructed or why I think they should be built. And these opinions have been fermenting for a while, and I'm just now starting to kind of come to grips with, my thoughts and my feelings on the space. And, this is a great opportunity to articulate some of what's been on my mind. I don't know if I really have it all figured out yet, but I appreciate the opportunity you're all giving me to give it a shot. So thanks for indulging me. But first a bit about me and why I think I might be qualified to talk about some of this stuff. So as Keith mentioned, my current role is heading up infrastructure, machine learning, and the feed product, engineering for it, at Instagram. But most of my background is in the domain of software tools, specifically programming languages, developer tools, compilers, that kind of stuff. At Facebook, I've been kind of involved with most of the language projects we've had cooking for the last few years. Hack, Flow, done a lot of work on Python, also some work on probabilistic programming. But some of you might already know me from some of the work I did with some really amazing people at Apple on Swift, or some work I did with some really amazing people at Microsoft on TypeScript or F# or JavaScript, Visual Studio. Before that, I did a bit of work on Office for Mac by way of GCC, which was pretty fun and interesting. I did some compiler startups too. So I've been around the past couple of decades, mainly working in the same space over and over again. I'm kind of a one-trick pony in that regard. But I do want to stress that everything I'm talking about today isn't specific to any one project or technology or employer or team I've worked with or may work with in the future. These are all my hot takes. And I should also admit that, yeah, the title itself is a bit of a provocation. And I kind of want to get into a little bit of why I think that there are lies being told, or maybe lies I've been telling myself. So to start, I kind of want to rewind the clock a little bit. About 4 or so years ago when I joined Facebook, some of the folks there were nice enough to ask me to do a Q&A. And going into the Q&A, I was prepared to answer some questions about some of the languages I've been working on, like, Swift or TypeScript, like why isn't there async in TypeScript yet at the time, or why isn't there async in Swift? But the first question I got right out of the gate was like really direct and straightforward, which was just like, hey, like, why do you keep switching jobs? Because basically, like, I've been lucky enough to work on some pretty, I guess, popular technologies, some things that have been adopted pretty widely. But those of you who know me know that I don't really often talk about sort of the pros of this stuff, and I do tend to move around a lot. And I also like rarely kind of really evangelize for these technologies after I'm done working on them. I tend to just kind of move on to the next thing. And people sometimes I think get the impression that I'm not proud of what the teams I worked with did, and it couldn't be further from the truth. I'm very proud of them and what they accomplished. But that question kind of got me to sort of recognize or really ask myself or introspect, like, why have I had this sort of sense of attachment? What brought me to these things, and what made me move on, maybe a little bit earlier than I should have from these projects? And to be perfectly honest, I think the reason why was because I started working on these projects mainly out of very selfish reasons. For each one of those technologies that I listed before, I was really, really, really lucky to have been there to help develop them and work with the incredible people that I did to kind of bring them to fruition. But the angle that I was taking in taking part in those projects were always sort of more out of kind of wanting to test myself, wanting a challenge, wanting to learn about a new domain, or just learn new things, or see what I could do stepping into a new space. Before I started helping out with F#, I really hadn't had that much exposure to functional programming languages. And before I started helping out with TypeScript, I'd never like really written a line of JavaScript, but I wanted to learn. But there was a problem there. And even though I think these tools, and technologies, I think, wound up in a good place, again, largely thanks to the awesome teams that were working on them. When I was working on them, I was never really thinking about who was going to use these tools. I was only really ever really thinking about myself, or what I was not really going to get out of it, but like, the things that I wanted to learn, the very personal and specific reasons why I wanted to work on these technologies. And then by the time I was deep enough in to get a real perspective and get feedback from users, I was often very frustrated because I had my chance to fix things that I would have otherwise noticed were wrong, but because I wasn't focusing my attention or passion in the right direction, I wasn't really able to do much about it. And that led to a sense of frustration and eventually me moving on. So basically, a large aspect of this talk are going to be the things I wish I knew going into those things, and the things I think we could have done better. But kind of taking another step back again, it's like my job today is very different. I mostly support large infrastructure teams, like hundreds of people working on a variety of different technologies. And at this point, I've probably spent as much time managing these sorts of projects as I have, actually contributing to them directly as an engineer. And a lot of how I spend my day these days is sort of talking to engineers, who are just like I was a decade ago, who want to do the same things that I did a decade ago for similar reasons that, I used to motivate myself a decade ago. And then now my job, being on the other side of the table, is trying to convince them not to do exactly what they wanted to do, using the same logic that I used to try to trick my bosses, forever ago too. So I occasionally know better in these sorts of situations, but, I sort of like my kind of paying for my sins of the past is sort of dealing with repercussions of the mistakes that I made and also preventing others from making them for me. So hopefully out of this talk, you'll get the sense that I'm not a total hypocrite, but really my objective here is to kind of present both sides of the arguments and where we go astray. But I think with that in mind, I want to kind of talk about just sort of the general set of circumstances around tooling in industry. I'll say that, a lot of the talks that have happened today are really great from an academic perspective, and I really wanted to present sort of maybe a more industrial perspective to what goes on behind the scenes. And, specifically, I think that a lot of what I have to say today is informed by three big problems that I think exist with tools development in industry. The first is that nobody is in control. And I mean that in the broadest, but also the most specific way possible. Like for all of you as engineers, if you sort of think about what the modern developer experience is like, using these platforms that we work with every day, there's a lot of different stuff that we're all up to, but I think that the one common theme here is that like none of us are really in control of anything anymore. So your typical engineer, like, if they're lucky enough to be in control of the work that they do and how they do it, the very like the rudiments of what they use to get their job done, they're not in control of. So specifically, they don't control the operating systems or the SDKs. If you're an Android developer or an iOS developer, you don't really have a lot of say in how those platforms evolve or are developed. You don't really have a lot of say in terms of how those SDKs are structured or designed. Even, in many cases, if you work at those companies, like if you're an engineer at Google or at Apple, you have your own sort of, marching orders. You have the things you need to be working on. You may have specific opinions about how these things are developed or what the priorities should be, but oftentimes you're dealing with a rubric of priorities that are much bigger than you or your team, no matter how much oversight you have. And to that note, like, again, even if you work for these platform vendors, you often can't tell them what to do either. You can make suggestions sometimes, or if you are lucky enough to work for a large enough company, you can make recommendations, but it's not really up to you to, kind of make sure that these recommendations are enforced or heard. Finally, the tools that we have, we're not in control of them, and they're usually not that great. I'll just be honest. And this is someone who's coming from someone who's actually like worked on these tools, cared deeply about them, worked with like lots of really talented and amazing and dedicated and passionate engineers building them. But, it's like, I think we can all agree that no matter what we're doing, oftentimes the tools that we're given leave a lot to be desired. And I'll get to the reasons why I think why in a moment. But the bigger point here is that because of all these challenges and the lack of control, we essentially try to focus inward. We can't affect the world outward, so we focus inward and we try to cover this gap. And so, again, going back to developer tools, especially coming from these platform vendors, I think, the gaps tend to come not from a desire of them to build bad tools. I mean, I did a quick search for Android Dev Studio, for Swift, for Xcode, for Visual Studio, and I could see all these criticisms, almost as much criticisms, people asking like well-meaning, well-intentioned questions. And it's like, why? Like, these tools can do a lot. They do so much. They provide so much value for people, but still people really kind of always have problems with them. They tend to hate them. And I think it's like we're engineers, we tend to be grumpy about anything that we're given, but I also generally think that tooling vendors have an impossible job. It's like, just as we're not in control, it gets to the second problem I think exists with tools in industry, which is that the problems we often face as tooling developers, they just scale better than our solutions. Like problems that we deal with are just bigger most of the time. And then no matter what you're trying to iterate towards as a tooling developer to satisfy certain problems or constraints for your users, it'll never be enough, and by any definition of enough. So like, if you think about the challenge that tooling vendors or tool makers face, I mean, they're just like legion. So, first and foremost, like internally within the company, within these companies that produce these tools, a lot of developers themselves often can't, not that they don't want to, but can't use the developer tooling that the company itself provides. So, I don't think I'm spilling any beans here by saying that if you talk to an average developer at Apple, some might be using Xcode, but a lot of them might be using Emacs or Vim or the command line, just for various different reasons, various constraints for the projects they're working on. Likewise at Microsoft, I worked in the org that built Visual Studio, and we're really proud of what we were building, but we looked around the company for various reasons, whether it's code base size, hardware controls, other things. A lot of folks weren't using Visual Studio. They were using, all sorts of different stuff to get the job done, because that's really all that mattered. Second problem is that, it's really hard when you're building these tools to get a good sense for the scale of problems that your users are going to be facing. And by that, I mean, it's like, you're working on an IDE at a company, and you have only so many resources to devote to scaling this tool out, to making sure that it can cover code bases of a certain size. And so you ask yourself, like, well, what is the average size of a code base that I should be catering towards? And I've been on the other end of these studies a couple of times, and I can tell you that normally it comes down to the average project that a lot of these IDEs are kind of being developed or focused to kind of work off of are like 30,000 line code bases maintained by 1 or 2 developers. So by industrial standards, fairly modest, but that leaves a lot of headroom for those of us who work at larger companies or larger operations to kind of, like leave a bit of space for these developers to cover. And, it's not that they don't care, it's just that these tool makers have their hands full trying to cover the basic scenarios for, much more modest means than what a lot of users have. And, frankly, like there's just a lot of space there. I mean, when I was working at Microsoft, for instance, we had this one project that would float around to help us stress test Visual Studio, and it was about 7 million lines of code. And back then that felt like a big project. And for years, compiler teams that I would manage, I would use the 7 million line code base as the boogeyman to make sure that your algorithms like can scale, make sure you don't go quadratic over the place, because someday some user is going to throw a 7 million line code base at you. But then I got to Facebook, and then I'm dealing with code bases that are like 2 orders of magnitude larger than that. And it's like, oh yeah, maybe I do need to rethink things. Maybe this whole machine learning thing is, adding up to something. And I think it kind of gets to the heart of the matter, which is that it's just really hard as a tooling developer to get it right for everyone. Because no matter how big your internal usage is, like somebody else is going to scale beyond you. Like another example would be that when I was, and this probably isn't spilling any beans either, but when I was years and years ago, when I was working at the Macintosh business unit at Microsoft, and it was just after the announced transition to Intel for Macs, we were trying to move Mac Office over to GCC, and we had a hell of a time doing it. And it's not because GCC is a bad compiler; it's an awesome compiler, and it's not because it doesn't scale; it scaled great. But just for that size of code base, it was just much larger than anything that the compiler teams we were working with at Apple had encountered yet. It was bigger than their operating system, bigger than their internal tools, bigger than their apps. So we had to really work really closely with that team to help it scale for everything from like debug information to template metaprogramming errors. And another example would be that when we were working on TypeScript, that original 0.8 release, we sort of made the same mistake where we thought like, oh, well, we'll focus this on 30,000 line code bases. We'll try to get the language right. And I kind of made a big mistake because I didn't realize how easy it was to port over JavaScript code to TypeScript in those first versions. So immediately I had engineers telling me like, yeah, not enough. I've got 100,000 lines of code here. This tool's not scaling for me. You need to fix this. You need to write another compiler. And so it's just really hard to kind of get this right because oftentimes when you're building these tools, you're working in a bit of a vacuum, an information vacuum. Finally, the other kind of way that the problems don't quite line up is that frankly, a lot of these tool teams are staffed by really passionate engineers, but who are specialists in their space. And this is touching on a theme I'm going to repeatedly go back to today, but I'll just say right now that I think a lot of you who've worked on compiler teams or worked in the languages field are familiar with the phenomenon of the compiler engineer who doesn't understand the target language that they're compiling for. The only code that they ever write in that language is contained in a folder called test. And the only files for that compiler are called like, test1.foo, test2.foo to stress test the compiler, test out certain compiler bugs. Unrelated to this, but very related to this, I'd say that the third problem is that also new tools are just too easy to justify in industry. It's like we have a lot of work that we need to do. Again, I keep pointing out that we have gaps to cover, but things can go off the rail quickly because it's just too easy to start these new projects to get things going. I think at the root of the matter are people like me who are, people who used to be engineers, miss doing the engineering work. And when a, very enthusiastic engineer comes to me with some great plans or some ideas to build something cool, like I want to live vicariously through them and say yes to everything. But, the reality is that there's just a lot of different ways that we can justify ourselves making these sort of dangerous decisions. And I outlined some of the fun ones that I've seen here today. So for instance, irrational exuberance, I think is one of the main ones I see. An engineer, they're starting to learn about machine learning or something of that nature, and then they get really excited about it, and then they start to see some to them would seem like really kind of powerful similarities or adjacencies with the work they're currently doing, and then want to map that over to the new domain. Intellectual tours de force is another one that I really love, which is basically you have a tool, it works, but it's not rigorous enough, so you want to kind of re-implement it in a more fundamental way. Hubris is a really popular reason for building new tools, either through the second system syndrome, where you have a team and let's say that they built a really awesome C++ compiler, and then they're really feeling themselves and like, well, screw it, we can build a new language now, we can do anything. C++ is hard and we're awesome. Or also experts, where it's like, again, you see this a lot in machine learning where you have a team of people and they really know software engineering, they really know tooling development. They look at the tools that those domain experts have created themselves and they say to themselves, like, look at those clowns, we could do much better than that. Herd mentality, language X has a package manager, so now language Y needs a package manager, or company X has a package manager, so now we need a package manager too. Build systems, I don't think I even need to kind of abstract that into any kind of metaphor. They just pop up everywhere. Like I would say that like if you have an engineering organization over maybe 500 people, like the likelihood that you're going to build your own build system increases quadratically with every engineer you add after that. Like we just all seem to have them. Finally, like you have the two sides of the coin. Either your boss told you to do it for strategic reasons. Oftentimes the tooling organizations of big companies are cost centers. So, whereas there's a lot of intellectual freedom to do work that you care about, sometimes you have to really kind of play to a company-wide strategy. I remember when I was in developer division, it was like Windows at Microsoft. Windows or Azure were the important ones. And we were constantly thinking of different ways we were being told different ways we had to kind of cater to those platforms development, doing things like, say, WinRT. Or there's the other side of that, which is that sometimes engineers just have so much credibility with an organization, or there's a cult of personality, that they could pretty much do whatever they want. So there's the whole, your boss told you to do it, or you told your boss. But I think, again, as I said before, the most important one and the easiest way to go astray is that because just, tooling development is fun, and, it's satisfying. So engineers want to do it. And, again, people like me want to live vicariously through those engineers because I don't get to write any code myself anymore. So it's hard to say no, and it just kind of happens. But if you kind of roll up those three things, I think what you'll pretty much see, and spoiler alert, this is sort of the focus of my talk, is that good tools, they require empathy, but in us developing tools, we often lack it. And, this might seem like a no-brainer, like, of course I should understand what I'm doing before I set out to do it, but it's just something that, in our exuberance, in our desire to build new tools and to write new code and to help each other out, we often forget that. And these empathy gaps are, they kind of pop up. And so, this sort of gets to kind of like, before I was talking about how I, as an engineer, would justify these tools to my boss to get sign off to do it. But then, sometimes you got to know that you're fooling yourself. So you have to kind of justify it to yourself as well. And I want to be clear about this too. In talking through this, I'm going to talk through some specific tools, and I don't want to be like dunking on anybody specifically. I'm fine with building tools. But really, the thing I want to kind of say here is that oftentimes you can get the buy-in, you can convince yourself to do it, but cooler heads will eventually prevail. So if there's one thing I really want to prevent with this talk, it's sort of the construction of tools that get to 80% done, maybe a couple of years of effort, and then get canceled. Because that's way worse than just kind of saying no to something off the bat, or maybe finishing something that's not necessary, but seeing it out to completion. So really what I want to say here is just like, look at your justification and look out for some fallacies that I outline here. The first fallacy that I want to touch on is that better tools make developers happy. Might seem like a bit of a hot take, but stick with me here for a moment. So I wish we were all together right now, but because we're not, I want to ask you for a virtual show of hands. So the engineers in the audience, I want to ask you a question. When was the last time that a new tool solved your biggest problem? And by that, I mean, you were miserable on Friday, your code base sucked, everything was horrible about your job, you take the weekend off, you maybe blow off some steam, come in Monday, pull the repo, there's a new tool there, and like, holy crap, all my problems are solved, hallelujah. Now, okay, maybe this has happened to you. It does happen occasionally, let's be clear, but for those of you that happened to you, how many of you were just as pissed with this new tool after 6 months as you were with the original tool? So like, did it really solve your problem, or did it pass the blame? And for those of you who weren't pissed after 6 months, I bet you probably were kind of pissed off after a year. So this is a real kind of hot take here, which is that I don't believe, and again, this is me as a pointy-headed boss, that from a purely capitalistic perspective, most tools aren't a net improvement over what they set out to replace. And I want to be clear too, this isn't like, you think this being kind of a language-centric conference, I'd want to kind of dunk on C++. I was trying to find some public domain artwork to outline C versus C++. I couldn't, so just want to explain that here right now. But basically, if you start to look at things, it's like really what you're doing when you're building new tools sometimes is just trading one set of problems for another. And sometimes in your desire, because you're sort of the way that you're affected by the problem at hand can make you rather emotional. As engineers, we're passionate and we want to do good work. And if something's getting in our way, we're going to get pissed off about it. So we'll be all too happy to move on to the next thing if we can, without really thinking about where that road will take us. And then after that fact, we've already gone so far that it's just kind of the devil So like an example here would be, for instance, like tools that were built for speed. So you have one tool that you're working with day to day and it's really slow and it sucks. And then sort of like you move to a new tool that sort of solves that problem, but then that move, requires more development and, more people kind of get wrapped up in it. And then after a couple of years, that becomes the bottleneck itself. Another sort of a line hot take I have here is that I just want to be real when it comes to this sort of stuff, that my observation has been that other developers' problems probably aren't as acute as we think they are, or they'll survive. This might seem pretty harsh, especially coming from a manager. Like, I don't want to be unsympathetic to the plight of engineers, but I think too often we use sort of the suffering of each other as engineers as justification for kind of taking foolhardy measures. We should switch from language X to language Y because language X has bad library support, despite all of the ecosystem work that the team has done. Or we should move from, UI framework X to UI framework Y, because this has been a little bit hard to work with. And, when we do the company morale survey, we're getting poor scores. So we need to do something to rejuvenate the workforce. But we A, really need to think about the ramifications and consequences of our actions. And B, we also should acknowledge and respect the resiliency of engineers of each other. I mean, a lot of what we do in this industry is work on the bleeding edge, and that's the frontier, and some amount of suffering there is just going to be inevitable. But we've learned to be resilient. We've learned to cope. We've learned to push through things. And sometimes I just don't think we have enough patience. We don't push through hard enough. And before we adopt new tools or give up on trying to improve what we have. My final hot take here about the acuteness of developer problems, and this is an especially hot take at a languages conference, but after years and years and years of working on languages, I'm becoming less and less convinced that new language features, after a language has reached a certain point of maturity, are really worth it. And so I know a lot of people, especially folks I work with, are going to be pretty angry at me at saying this, but just hear me out. You have an existing tool chain or an existing language. You want to add a new feature to it, but normally you're working in the zone, you're working in the domain of language. You're not really thinking about all the other ramifications that might happen. You're just kind of thinking about a specific problem you want to solve for your users. But those other ramifications could be severe, things like compilation time or binary size or output speed. And I think it's part of it is that a lot of us are so excited and kind of tuned into languages that we just don't think of these, again, the other ramifications that might come through. And we have such a single-minded desire on satisfying our users, other engineers, that we don't often think about what the ambient costs would be. Because emerging complexity is a real problem here. This graph I have here, my wonderful MS Paint art, is something that I often write on whiteboards when I'm sort of welcoming new language engineers to my teams, which is that, you can sort of think of your language as a composition, as a grid of features. And usually or oftentimes as language engineers, we tend to kind of explore, just sort of the axes of the graph. So you see that full part there is where just syntax meets syntax, because syntax is the easiest thing to think about. So that's the thing we like to shit about the most. But further down the line, we tend to think about sort of in isolation how different features might compose with one another, but not exhaustively. But then our users who are trying to do real work, they just go way out there, and they're just not playing in the same place that you are. And so whatever you give them, they're going to take to the nth degree. And your job is going to be to try to explore and to kind of catch up really quickly with them. And so you're buying on a lot. And so whereas, again, I often see new language features proposed, and if I do see them vetted, it's often vetted objectively in terms of the language itself, and not in terms of the effect on the tooling ecosystem, what it'll do to the compiler tool chain, what it'll do to the IDE tooling, what it'll do to the package manager, the build systems. It's something to kind of consider, to weigh the cost of new language features in a more global sense. All right, so my next fallacy. All time spent on new tools is time well spent. Emphasis on the all. So for this one, I kind of want to explain it using a bit of a thought experiment. And my thought experiment is to ask yourself the question, did we really need Swift? Now, this is not to single out Swift. I love Swift. Obviously, I'm very emotionally attached to it. And you can have the same argument for a variety of other kind of technologies that kind of use types as one of the main selling points. But I thought this might be an interesting one because whereas many new technologies for new platform plays had weak incumbents, ones that were unpopular or evolution had stalled, Swift didn't. Swift had Objective-C, and you could say a lot about the quality of Objective-C, or not the quality, but rather how modern Objective-C was, and whether or not at the time Swift was introduced, it was sort of meeting the needs of modern developers, but it did have a very strong and committed user base, which I think makes Swift an interesting case study to explore. And I think some of this honestly comes down to sort of why we would do new things comes down to kind of a mix of marketing and fashion and also hindsight being 2020, like revisionist history maybe, but also just self-justification. And I know that's a bit of a ramble, but where I'm going with that is that if you look at sort of like when we talked about Swift, when we launched it, what were the benefits of it? And a lot of them were wrapped up in sort of, the benefits of typing and the things that strong or static typing could do for you in comparison to Objective-C. They could lead to safer code. They could lead to faster code. They could lead to better tooling opportunities. And of course, just by building a new tool chain, we had an opportunity to do a lot of things right, like pave the way for things like Swift playgrounds, which I think have just been fantastic. But there's a lot of downsides that come with breaking new ground and exploring things. So, we took on a lot of new problems that weren't really as acute in Objective-C. things like build speed, whether it was for the front end, just a type checker that has to work harder, or the back end, an optimizer that has to work harder, compilation was slower. Larger binaries because of things like inlining, and challenges like ABI stability, which for a language like Swift that the ecosystem wasn't as accustomed to, like were actually very meaningful to our users. And we knew these risks going into it, but we built it because we wanted to do better than Objective-C. We just had a lot of different definitions of better. But if you kind of look at the time and the energy that were devoted to Swift by a really phenomenal team of world-class engineers, you do have to ask yourself, again, like, what if that time and energy had gone to other aspects of improving other aspects of the ecosystem, improving Objective-C even more, putting more time and energy into the client static analyzer to win back some of the correctness and safety advantages that we claimed only types could provide? What about just improving Xcode integration in general? At the time, it's sort of Xcode was undergoing a rewrite. There were some aspects of the functionality that hadn't been re-implemented yet. There was a lot of ground there that needed to be covered. Now, I do want to say we did all the right things with Swift, I thought, in that we went in with clear eyes. The team had already tried for years to drive the right kinds of improvements to Objective-C. So they weren't really operating with hubris so much as they really did feel the desire to do new things and to have a new take on things. I thought the team was awesome in that regard, but I rarely see teams enter in such big decisions with that level of kind of introspection. And again, that recognition that new tools often mean new problems. And sometimes you get lucky when you're introducing those new problems, and the new problems you introduce or replace the old problems with are less serious or more tractable than the old problems, but sometimes they're not. And also, generally speaking, big problems rarely require a whole new approach or tooling story. I mean, a thought experiment I would recommend is to think through, like, what was the last problem you were aware of that required a completely fresh or radical new take on tools? I can think of a couple. Like deep learning is one. I think that there's been like a justifiable explosion in the tooling ecosystem around machine learning because of just the prominence of deep learning today. Spreadsheets is another one. But if you look at sort of how kind of at the pace that these new problems are introduced versus how often we introduce new tools or new technologies or radical new takes on things, there's something out of step there. Like you can maybe name 2 or 3 of these new like revolutionary problem domains, but you probably can't name 10. And the last thing on that note is that, again, we need to kind of recognize too that these new tools swapping into the new problem domain, they're a commitment. I know a lot of engineers who, kind of went into developing a new tool with a lot of excitement, only to find out that, this became their life and their job for years to come. And so we really do need to ask ourselves and kind of go in with open eyes about like the time it takes to build these things, the effort to support them, and where else that effort and energy can go. All right, my next fallacy is that good tools can be built to solve unfamiliar problems. And so I just want to kind of call this out because this is probably the, in modern tooling development, the fallacy that I see deployed the most, which is I touched on it before when it came to hubris or arrogance or just the fact people are excited about a new domain, which is so essentially an engineer starts learning something new in their spare time, and then they start to see those connections, or they're a pro or an expert in what they're doing, and they see what other domain experts are doing, and they want to kind of introduce some good old-fashioned rigor into this, and then they just make a huge mess. Like over the course of my career, for instance, I've been involved in sometimes directly, sometimes indirectly, a number of different efforts to try to build better tools for the financial industry. And all of them were kind of based, all of them failed, unfortunately, despite like the really sort of, I would say, direct and important efforts of some really amazing people. But I think because it's sort of like, they all started with that fundamental sort of misconception that these folks working in this different but deceptively familiar domain didn't really know what they were doing because they were doing things differently or with less rigor than us. And after seeing a few of these efforts go through, I kind of was left with the conclusion that maybe the best thing that software engineers could do for people who aren't software engineers but have software engineering-like problems is just to leave them alone. I feel like us leaving them alone would probably allow them to be more productive than any kind of tooling benefit we could provide them. And I see this a lot today, especially now with like the machine learning domain, where essentially I feel like we're making a lot of these mistakes again that we made 10 years ago with like financial and mathematical computing. But like, I don't think most engineers are really that arrogant. So why does this happen so often? And, you know, I think it happens for a number of different reasons. Like learning and discovery is good, scratching an itch feels good. You put them both together and then you add the fact that we could help people, like that feels great. So a lot of well-meaning engineers want to do this. They want to go out and just help. They're feeling altruistic. It starts with a feeling of generosity, and who could argue with that? But I think sometimes we have to remind ourselves too that, you know, we are professional problem solvers, but not every problem is one that needs solving by us. And also, if you're, you know, if you're entering into sort of building a new tool with the perspective of this, like if you want to kind of replace a tool that's built by amateurs who know their, you know, domain with one that you introduce, I'd rather take the one that's built by the amateurs who know their domain over the one that was built by us who doesn't, if that makes sense. So basically, like, let the machine learning researchers do their thing. Let the quants do their thing. And then it's not to say or discourage you from trying to help them, but if you're going to embark on trying to help them, you know, really try to deeply understand the work that they're doing and why they're doing it. And, you know, these being smart people are probably aware of the work that software engineers do, why they haven't already kind of opted in or engaged in sort of taking on some of that work themselves already. And if you can think of new ways to help them, I think the best way is to try to kind of help them build their own tools if possible. I think we forget that so much. I think we want to cater to them. We want to solve their problems for them. It feels good. But sometimes the best thing you can do is just empower them to do their own thing. I'll say here too, actually, this kind of reminds me of one thing, which is that, like, you know, it comes up a lot for me where having worked on, and maybe for some of you, having worked on a bunch of languages, I've been approached by like pretty like ridiculously and scarily accomplished people who think like, oh, you've worked on languages, let me ask for your insights in making my tool chain better. And like, they're always like a little shocked or very disappointed when I can't, because I think it's like the only insight I've ever had in this is like how to get paid doing it. Like they're the domain experts, they're already doing world-class work. It's like, there's not much that I can really give them other than to say like, it's probably not a language problem that you're dealing with. And I think this kind of is, you know, there's a corollary to this too, which is that I think good tools support, improve, and they co-evolve with ambitious systems. So it's, you know, if you think about good tools development, it's never about us stepping into a new domain to solve somebody else's problem, but really it's a byproduct of solving our own problems. Like, I think this is very, very, very sort of important for language technologies, you know, to make sure that they're coming from have an editorial angle of purity to them. But if you think about C's relationship with Unix or Rust's relationship with Servo or you know, Hack's relationship with Facebook's web code base or even, you know, PyTorch's relationship with some very specific initial deep learning projects, you see that the through line there is about people wanting to get a certain job done, the tools not existing to do it, and then sort of, you know, filling their, or scratching their own itch or sort of, you know, kind of catering to that niche, but never with the objective of building tools, but with solving like another related problem. I think that there's something really to learn from that. My final fallacy here, which I've touched on a couple of different times, but I don't think good tools need to be rigorous. Good tools just need to work. So my favorite example that I tried out for this one is that, you know, again, working in languages, there's always these requests to engage in new language features, to develop new language features. Sidebar is that like one kind of disturbing thing I've seen is that a lot of engineers I've been working with lately who've, you know, working on languages have only ever really worked on languages. And I think, you know, that sort of empathy there is missing, which means that they want to do it. I wish more engineers would do a tour of duty on a product team from time to time. But anyway, we were able to put astronauts on the moon without all these fancy new language features. Like it's amazing what you could do with an, you know, just like a really stellar software engineer and a macro assembler. And I think we kind of lose sight of that sometimes, where we want to add more kind of conceptual rigidity to language, to languages or tools, like to kind of, you know, stop engineers or developers from hurting themselves, when the reality is we should really be trusting them. We should be trusting their expertise and looking for ways to kind of aid them, but not overrule them. You know, and also, okay, fine, like people probably were intuitionally using constructs like monads in assembly or whatever. But again, it's like, I think the point still probably holds. But truly exceptional engineers with sufficient motivation can really do anything with any tools. My corollary to that too is that Excel is good. Okay, this is another thing where like we always like to dump on Excel or think that people using Excel are clowns. And I think the same goes for R as well. Like, you know, we point to this as an example of why shouldn't they be doing software engineering? Why is there less rigor there? Why is this, what are these weird tools that have like, you know, strange and sort of very organically grown semantics that, you know, our language designer brains that think in systems have a really hard time coming to grips with. But again, the reality is that not every problem is a software engineering problem, and it's not everyone is a software engineer. And if if tools work for users and they self-select towards them, we should respect that and look for ways to help them. All right, so thank you for bearing with my rants on all this. I could go on and on and on, but I'm running low on time, I see. And in the interest of keeping these 40 minutes productive, I think I kind of want to end on maybe a note of optimism. So I'm just trusting that none of you are going to listen to anything I have to say, and probably shouldn't anyway. But if you do choose to embark on your tooling journey, there's just some bits of advice I really would like to hope you would all keep in mind in sort of thinking through the development of your tools. First and foremost is to think of the user. Now, by the user, I don't necessarily mean the software engineers that you're building the tools for to use. So it comes as no secret, I work for a company that's named after an app. Many of you probably do as well. I'm talking about those users, the people who, the end users, the people whose decisions were really affected by on a product basis. You know, it's like too often we think about, you know, tools and how they'll kind of affect our buddies, the other engineers, but you know, many of us work in the commercial environment. It's a commercial enterprise, and you know, the business can absorb a lot of the work that we do, but you know, it's all about the user perception and the value that we're providing them. So I really do feel strongly that good tools should have a through line to the eventual end user, to the civilian, if you will, who's you know, using what the engineers at your organization are using to build. The example I like to try out a lot is like, is the technology you're building like a text editor where the other engineers can use it, but it'll never be felt by, you know, the users of your application? Or is it something that could, you know, potentially resolve crashes or make it more performant? Things that really will have a tangible and palpable benefit to the users at large. And open source can be a distraction here, I'll admit too, because then you're kind of basically bifurcating your user base and then you don't know who to please. So I love open source, but it can be a bit tricky to navigate when it comes to tooling. Second bit of advice is to build tools that you could finish and not abandon. And by that, I mean, if you are considering embarking on your tooling journey and can't think of an end state, maybe you should be rethinking your objectives here. So try to kind of find bounded problems to work on, apply the Unix philosophy. And also, frankly, if the system is broken, try to hack on the system rather than build new tools. I think you'll get more value out of it anyway. But try to scope your work carefully. Think about what done is like, because if you can't picture an end state, you might be overscoping, you might be taking too much on, and basically it's just going to lead you astray. Finally, I kind of stated this before, but I think it bears repeating. Please don't set out to build tools, set out to unblock progress towards solving important problems, because tooling should be a byproduct of ambition. I think the best tools are conceived by people looking to solve bigger problems. And they can't wait to get back to solving those bigger problems, not investing in tools for themselves. Because the tools, they shouldn't just accelerate progress, but they should also compel others to do your job for you. They should, you know, spread out the work and get more people on board. And that's basically it. That's basically all I have to say about this in this rant. So to sum up, again, the problem that I'm trying to explore, and maybe I did a worse or better job of articulating it than I thought I'd be able to, is many new developer tools are built for the wrong reasons. And what I'd like you all to consider when, you know, thinking through whether or not you should build new developer tools is, you know, one, empathy matters. And then to also know your audience and consider the following questions before setting out to build them. One, will this tool benefit your app's users? Two, can the tool ever be finished? And three, are you unblocking progress? And there's a bonus fourth one, which I haven't touched on yet, which is that, did you take what I said today too seriously? Because the world does need better tools. I don't want to stop you or discourage you from doing that. Really, I want you to take all of my advice from your grain of salt. And if there's one thing that you get out of this today, it's that just be true to yourself when you're considering building new tools and follow your ambition, because you know what to do best. You know your domain, you know your circumstances, just be careful. So thank you all for listening to my rants today. Really appreciate it. And on to the Q&A.